So good afternoon. I'm Danilo, and I'm a project manager at Legal Labs. I'm thrilled to be here today with you all, so thank you for the opportunity. And I'm here today to talk to you about how we at Legal Labs applied machine learning to judicial decisions. So in this talk, I will briefly talk about how the judiciary is organized today. I think it's important to you to know how we work in Brazil and how we tackle the problems and how we saw the opportunities that were available in this sector, and what are the solutions that we developed to tackle these problems, and some things that I think are gonna come in the next few years. So for the judiciary overview, we have today, currently, a judiciary built upon 3 building blocks. The first stage is where the common judges first analyze the cases that are brought to attention by the government's attention. So here we have 5. I think it's best to use this. We have 5 open doors for the public to file their cases. And when this judge analyzes these cases and file a decision, the parties have an option to appeal to that decision, and then the case goes to the second stage. On the second stage, usually there are a group of judges that then analyze this case, and then they can agree with the last decision made, or they can overrule it with a new decision. And usually the parties have an option to appeal to the higher courts, and often this is done to gain some time, because on the higher courts, only the cases that have infringements directly to the Constitution that will be analyzed. So the cases that don't have this, they are brought down, and then the process ends these final steps. So, but this was not always the case. On 1988, a new constitution was made to bring this to turn this possible. Before this time, the judiciary was very difficult to access. Only the people that have the money or the education can have access to the judiciary. So the power to talk to the states before was really scarce. And when in 1988 a new constitution was made, and the doors to the judiciary were open freely to the public. For that, we had an exponential growth on the process. Before this constitution of 1988, we had around 400,000 process, and back on 2014, this number scaled up to 100 million processes. So this was on 2014. On 2016, only in this year, around 28 million cases began, and 28 million cases were terminated. But this did not mean we were in a zero tie, because the cases that were terminated, they were terminated on the case that were already on course for a few years. There was an inventory of 1790 million cases to be processed. So it's not a surprise that in Brazil we have the biggest court in the world. Only in São Paulo there are 24 million processes that are on course today. And with Rio de Janeiro and Minas Gerais, we have half of the process from Brazil. And along with 19 other appellatees instances and the higher and supreme courts, the workforce that needs to deal with this process are around 442 million people This is around the population of Roraima only. I think this is not right to deal such a workforce for this kind of problem. A lawsuit takes place around 2.5 years to 7.5 years. So when I filed my petition today, I have to wait around 2.5 years to have my appeal written by a judge, a decision made about it. So this kind of problem can spread really quickly on the culture of Brazil. So with this problem, we are creating a sense of injustice for our population. And this reflects on our culture also. And for that, there are really big problems that I cannot cover on this presentation alone. So this is a bigger issue than we imagined to be. And all these facts add up to an expense of 84 billion reais of expenditures. So this is only in the year of 2016 alone. So again, I think this is not right to have such simple cases to demand such expenditure on them. But again, the people in 1988 thought of the entrance door. They didn't think of the exit door. So I think it's our duty now to design this exit door and build the hallway, a more simple and swift walk. So thus, we had Legal Labs created with this purpose. Legal Labs today is the most specialized startup in artificial intelligence applied to law in Brazil. We mostly credit this to our team. Our team is a multidisciplinary team. We have AI software production engineers, data scientists, and most important, jurists. We have to get these two words to collide. We have to get these two words to talk. This brings much more a solid grasp on this domain. And we think this is important to propitially engage in positive discussions that lead us to great products and design. So we think that this talk has to happen. We think it is only through this talk that we will build solutions to the problems I showed you earlier. And with our recognition of that, Legal Labs today is listed as the sole company by AB2L as the company that applies solutions to the public sector in Brazil. We try to build solutions that will reduce the bureaucratic steps of the legal sector in Brazil. And for that, we are now listed in the global program of AI builders, along with a couple other companies in Brazil. And not long after being listed in this program, we have been listed in Codex Stanford program, is in the Hall of Global Legal Techs. And all of this was possible due to our passion to build this better judiciary in Brazil. So with all this problem, we saw the opportunity to apply machine learning and artificial intelligence because of mainly these 3 points here. We have well-defined steps on the law. The law defines and strictly apply these steps, so we have to walk all the way to the letter to finally have a decision. And this is a really repetitive work. If you are all day sitting on a bench, on a cubicle, you are doing all the time the same work. You are reading the same judges saying the same things and doing the same stuff every day. So it's really repetitive. And all the cases that are filed every day, they add up to an enormous amount of data. So for AI, this is a full plate to devour zone. And for all that, we built Doutora Luzia. Doutora Luzia was the first, is an impersonation, of course, so we had to that play here. But was the first software to use deep learning algorithms to automatically file petitions, judicial petitions. So Dr. Luzia was created with the goal to impact the speed of procedural steps in the tax execution. This means that Dr. Luzia works on the side of the government, on specifically the tax execution sector. So this niche of the tax execution, let alone have 32 million cases awaiting for trial. Tax execution is the legal sector that deals with debtors through for the government. So we, as a government, have to file petitions to seek these debtors to fulfill the debts. It's basically that. So all of this adds up to the 30% of the total court cases that we have here today in Brazil. And all these cases, they are really repetitive, really repetitive. Only they are gathered up around 60 to 80% of this process are gathered around on the same steps, waiting for the repetitive work to be done. So seeing this situation presented itself as a major opportunity. So our team take this challenge and we build some steps, some general steps to build a solution for a problem in the judiciary. We then, around our researches, we found that these steps are mainly the same for every industry. On a talk around a month ago, the AI director of Tesla, they said the same steps were really important to build a really good solution to any industry. Basically, on the steps that are about gathering data, because on the industry we don't have data delivery to our hands like academia does, and we don't have label data to do supervised machine learning. So these are basically the steps of a building, they are the building stone of a good solution. So all of this lead us to the extract, transform, and load step. As our colleague said on the previous talk, we have to build scrappers and crawlers to go to the court sites and then collect the data. The data is freely open, like he said on the last question, is strictly open by laws. So it's okay to go to them and collect it, use it. So we collect this data, transform it to JSON objects, and store it on the NoSQL database. So when we had our database structured and with clean data, we then were possible to draw some information out of it. With that, our team mapped 29 possible steps that the cases are in, and they need the attention of the attorneys. So there are a dialogue. The attorney says something, and the debtor says something, and the judge is the intermediary of them. So these 29 steps, the attorney has to build a response to it. And these steps goes through citation, when the two parties have to go through the judge and present themselves, until we have pony and asset seizure when the debts are fulfilled. So this was possible mainly because our multidisciplinary team. These steps are not available anywhere in the laws, on the books. So this was what the data told us and what we extract with the knowledge of the jurist team. So it's really important to have a team that has the knowledge and authority over the domain. So we can have better decisions to build simpler solutions with a great impact. So finally, we chose 5 of these 29 steps, and they only them added up to 85 of the work done. So as I said, much of this process are gathered up on one step or 2 or 3 or 5 or 10, and they are only waiting for someone to go there and just push them to move forward with the case. So the jobs of these employees that did this weekly basis work was to analyze decisions that the judge published, and these decisions are mainly short texts. They are easy to read, but they are easy to read to the employees. They already know the language, already know the jargons that the judges use. So as the previous talk told you, we had to build our own data. We have to label it. We have to go and do our work. So for that, we gathered this data and we applied it to our team, our jurist team, and then they built us a dictionary of most preeminent terms that we were then able to build regular expressions to maximize the likelihood of gathering positive samples for being labeled. But we also made some efforts to go and pick some data that were on the out sample of these terms. So we kind of want to generalize even more what the rejects told us. So for that, our data were put on some kind of system, and then our jurist then looked at what we were asking them. So we asked them, what is this? And then we had some options, like a test. We had some options. They choose one and next. Choose one, next. Choose one, next. So it's basically a mechanical task, but they are really fast and needed, of course, for our supervised machine learning. So having our labor data set, we then commenced to doing some experiments. For that, we tokenized our data and applied some text normalizations techniques, such as stemming and liming, to go to the radical of the words, and applied some bag of words representation. This was we applied this and this worked, so we went with the simple solution. The bag of words was working fine, so we did not went to word to vec or some other more robust techniques and more highly costly techniques. So then we used KNN to analyze our data, naive Bayes and SVMs to classify it and see if it was linear separable, what was the data telling us. So, but the final product we arrived were RNN, an ensemble of RNN and Ns with LSTM mechanisms. This was basically because the domain told us 2 of these steps were much entangled. So we built a simple model to disentangle these 2 classes and another one to go with the other 3. And then we have the 2 models competing with each other to classify a publication. So with this architecture, we have some major mechanisms, something like embedding to represent our bag of words in a more vectorial way and reduce the dimensionality of our tokens. We then apply a 1D convolution to look for local representations, and then an LSTM mechanism to build the sparse representations. like our colleague said, they're not up on the sentence and the decision there. They kind of have the relationship, so we have to link them to the final decision. So for that, we use the classic duo of Keras plus TensorFlow, and we trained it on 2026, 60% of 2026 labeled publications, and tested them with test the models with 40% of it. So after that, with this test, we arrived at a conclusion of accuracy of 99.42% with the worst classifier. The best classifier was 99.6%. And this was further evaluated by our jurists that conclude this accuracy was valid. And finally, we deployed the Dr. Luzia at an attorney's office and improved their tax execution legal sector. There, they have, before Dr. Luzia, they had 4 people working on a workload of 500 to 1,000 cases per week, and they took 5 days to go through all of them. So this was basically a run against the clock for them. So they did not have the time to go and have a more robust analytics and analyze more the process that should be analyzed more because they had numbers to attend to. So Dr. Luzia processed all this workload in under 2 minutes, only going through gathering the data, analyzing it, classifying it, and building the petitions to be filed by these employees. And this represented a 50 to 80% of the reduction of their work in a weekly basis because of that steps that we analyzed to be the most important ones. But one realization we had was that this not improved the procedures we had the goal we had with Dr. Luzia, because this is a 2-person dialogue. So we improve a dialogue of 1 person, but the other one couldn't keep up with our speed. So we must have the judges to have the resources and have the tools available to them to keep up with the speed needed for this problem. So we have some next steps that we think will come in the short years from now. We are already seeing some courts running against the EI war, something like that, because everyone wants to innovate. Everyone wants to be the good guy that solve the problem of the legal sector. So we have the Rio de Janeiro court today is innovating, is taking the first step towards this building stone. So today they are filing a new project to do some representations and some classifications much more alike the Dr. Luzia, but for the judge side. And this can translate in a tremendous velocity for the process, because if we have one reply, and then reply, and then reply, and then reply, and then we reach a point that someone really needs to analyze that case. So we build the half of the ladder until someone has to go and see some of the problems that we're dealing with. And I think when we have the 2 parties in an automized dialogue will be the day we have changed the legal sector paradigm. So, thank you.
Did you train a model for each state of the country, or use the whole data and your model understand the process of the whole states? You have a specific model for São Paulo, a specific model for Rio de Janeiro?
No, we start with one region, and with this region we were able to generalize how the judges talk on this region. For another region we have to fine tune it. So
Perfect.
Hi, thanks for the talk. I keep a close eye on legal labs for some while, but it's been like for too little time they're being trying to work with text, and then you guys, as the previous talk, start with the simple baselines, like bag of words and SVMs, and start building. On top of that, I don't know if you guys are keep tracking with the latest research on the field, like words on Jeff Dean. They are using skipgrams 2.0, and I saw that you guys use CNN plus LSTMs. On top of that, my question is, you guys have such a larger corpus of data that you never try to use some Google data set to import weights, a different language, or you always train your feature extractors from the beginning with like you start with random weights? That would be the question.
Yeah. The legal sector has their unique language. It's the legal sector Brazilian language. So we don't have this dictionary, these weights, and anywhere else. So we initialized and we trained our weights from the beginning. That was needed for the domain requested it. So I think this was your question.
So and the final layer, you have to use hierarchical softmax for the training time or the complexity, or not?
We applied a simple softmax solution on the final layer. This was the thing that was needed for the domain. So the hierarchical, I don't think there will be much more difference there.
Okay, thanks.